Welcome to Raw Machines, a journey into some of the most remarkable production processes around the world. Today we travel from the forests of Sünwald, where oak is split along the grain and bent by fire to become watertight wine barrels, to the Siebengebirge along the Rhine, where those barrels are hauled, carried, and fed into trade networks by human labor alone. Sünwald forms part of the Hunsrück Range, set apart from the Rhine Basin, where successive forested hills create a dense and secluded landscape. Here, the forest was not merely scenery, but the primary source of raw material shaping local craft traditions. From early times, villages along the forest edge made use of the available timber, with oak occupying a central position due to its strength and resistance to moisture. These qualities established Sünwald oak as the essential material for cooperage, the craft of barrel making. From the forested landscape of Sünwald, which provided the primary raw material, cooperage gradually took shape in villages along the woodland edge. The village of Ellern, situated on the northern fringe of Sünwald, became one of the representative settlements in this development. Ellern displays the characteristic structure of a rural craft village, where living space and working space were closely intertwined. The cooper's house stood near the village center, set behind a front garden, reflecting a form of craftsmanship embedded directly in family life. In the past, wine casks produced in Ellern were supplied to major wine-growing and trading regions such as Mosel, Nähe, and the Rhine Basin. At the same time, the workshop also produced essential wooden household items, including tall tubs and bathing vessels, showing that cooperage served both regional commerce and the everyday needs of the local community. The introduction of zinc and plated metal containers gradually displaced handcrafted wooden barrels from the market. As a result, coopering contracted to a local scale and ceased to be the primary source of income for craft households. Today, the trade survives only through a small number of functional orders, such as barrels for liquid manure, meat curing, or apple wine, Viertelstück, standing as residual traces of a technique that was once widespread and economically central. The cooperage process begins with the preparation of fresh oak, known as green wood, timber that has not been kiln-dried and still retains its natural moisture within the grain. In traditional barrel making, this moisture preserves the elasticity of the fibers, allowing the wood to be bent without cracking. The cooper selects straight oak logs with few knots and even grain, then splits them along the natural direction of the fibers to produce stave blanks. This is a decisive operation. Unlike sawing, which cuts across the grain and weakens the structure, splitting preserves continuous fibers, ensuring the barrel's ability to withstand hoop stress. Preserving the grain direction not only makes the wood more pliable during bending, but also determines the water tightness of the finished barrel. From this first split, the durability and function of the vessel are established, reflecting the technical foundation of traditional cooperage in Sünwald. After the oak has been split along the grain and its fiber structure preserved, the stave blanks enter the stage of rough shaping. This marks the transition from semi-finished material to components that already carry the functional geometry of the barrel. On each blank, the cooper lays out guidelines to define three functional zones: the upper end, the lower end, and the belly. The belly, being the widest section, determines the barrel's capacity, while the ends are left thicker to withstand the pressure of the iron hoops. These markings reflect craft knowledge accumulated over generations. Next, the sapwood near the bark and the softer inner core are removed due to their low stability and poor resistance to moisture. The remaining heartwood, with its denser fiber structure, is retained to ensure the strength and longevity of the staves in contact with liquids. Through shaping, the staves gradually acquire the required curvature in both length and width. The slight bulge at the center, combined with increased thickness at the ends, not only defines the characteristic form of the barrel, but also prepares the staves to be assembled into a closed circular structure. At this stage, the basic form of the barrel is established, even though its parts remain separate, awaiting the next step toward a complete whole. After rough shaping, the staves are stacked for natural air drying, often for at least one full summer. Slow drying stabilizes the oak, releases internal stresses, and reduces the risk of cracking or warping once the barrel is assembled. At the same time, the wood reaches a balanced moisture state that allows the fibers to swell again when in contact with liquid, an essential condition for watertightness. With the transition to fine finishing, the highest degree of precision is required. Using specialized planes, the cooper refines the curved surfaces of each stave, repeatedly checking them against templates to ensure uniform curvature. The belly is smoothed at the shaving bench, while the narrow edges are planed with exactness so that, when assembled, the staves meet tightly without gaps. For staves of uneven length, the belly notch is established as the central reference point. This mark serves as the geometric axis during hooping, bringing all staves into a single-dimensional system. Through fine finishing, traditional cooperage transforms the natural irregularity of wood into a stable, closed, and durable circular structure.
Ja. Kom maar raus.
Once the staves have been fully finished in size and profile, the cooper proceeds to assemble the frame. The staves are arranged according to their width and curvature, following craft standards developed over generations, ensuring that when raised they form a balanced circle.
Immer der dicke Kopf in Ruhe.
Each stave is set upright against the inner face of a shaping hoop placed at the base, which serves as the initial mold. Above it, several temporary hoops are fitted to hold the staves in position while the barrel body remains unstable. At the belly, the widest point of the barrel, the reference notches on each stave must align precisely to form a continuous circle. This geometric reference determines both the axis and the capacity of the barrel. Once the layout is secure, the process of fire bending begins. A fire is lit inside the barrel body while the wood is repeatedly moistened. Under the combined action of heat and moisture, the wood fibers become pliable, allowing the staves to bend gradually into shape without cracking. When the wood reaches the proper softness, the cooper successively drives the hoops downward, adjusting their positions to guide the bending forces. 3 hoops are typically used to close the still open end, after which a traditional chain or binding rope is slowly tightened, drawing the 2 ends of the barrel toward each other in a controlled manner.
Kommst du so weit?
Langsam.
Throughout this process, the alignment of the belly notches is constantly checked. From this reference, excess wood at both ends is carefully measured and cut away, transforming the barrel from a temporary cylindrical form into its correct profile, with a pronounced belly and tapered ends.
Kan we overblikken.
At this stage, a fundamental principle of cooperage becomes clear. Fire, when precisely controlled, ceases to be a destructive force and becomes a shaping tool. Through the combined action of heat, water, and mechanical force, separate staves are transformed into a closed, self-supporting circular structure, a decisive turning point in the making of the traditional wooden barrel. Once the barrel's form has been stabilized by the hoops, the cooper turns to working the inner surfaces at both ends. This stage follows a strict sequence using specialized tools. A knife is first used to true the inner edges. Chisels then level the ends of the staves, and finally scrapers and end planes smooth the surface, creating an even seat for the barrel bottom. When the interior is properly prepared, a crowsing tool is used to cut a continuous groove around the inside of the barrel. The groove must be uniform in depth and width, as the bottom is not simply placed inside, but fitted into the groove like a mechanical lock. This precise fit, together with the natural swelling of the wood when exposed to moisture, secures the bottom firmly and ensures the barrel's water tightness. Once the barrel body has been raised and stabilized with temporary hoops, the cooper proceeds to make the load-bearing iron hoops that will replace them. At this stage, the circumference is measured directly at different points, from the belly to the shoulders and the ends, since the barrel is not of uniform diameter. A traditional measuring cord, often made from tree bark, is wrapped around the body to obtain the exact size, which is then transferred to the iron strip. The iron is cut, bent into a circle on the anvil, and riveted or pinned to form a closed hoop. These finished hoops do more than encircle the barrel. They apply even compression around the circumference, locking the staves together and preserving the barrel's form over long use. During fitting, the cooper drives the hoops down to their precise positions, ensuring uniform pressure and preventing misalignment or open joints. At the same time, the barrel bottom is made from edge-joined oak boards secured with wooden dowels. The rim of the bottom is beveled to fit into the crows cut inside the barrel. At the joints between boards and where the bottom meets the groove, reeds may be used as packing material. Their fibers fill minute gaps and swell when moist, improving tightness without the use of adhesives. Once the bottom is set into the groove, the iron hoops are driven further down and tightened to lock the structure. At this stage, the barrel becomes an integrated system governed by material principles. Iron provides compression, wood bears and shapes the load, and natural packing ensures tightness. Water tightness is achieved not through glue, but through precise geometry, hoop pressure, and the natural swelling of wood when exposed to moisture. When the barrel structure has been fully secured by iron hoops, the cooper turns to the final surface finishing. Marks left by hooping and shaping are removed with finishing planes and scrapers, leaving the body smooth, even, and free of sharp edges. This step eliminates the last traces of rough labor, bringing the vessel into a condition suitable for practical use. Before any protective treatment is applied, the barrel undergoes a water tightness test. Water is poured into the interior to check all joints, the bottom, and the body. As the wood absorbs moisture, the fibers swell and tighten the joints. Any minor leaks that appear are corrected at this stage, and only a barrel that holds water reliably is considered technically sound. In the final stage, the outer surface of the barrel is rubbed with a layer of linseed oil. This treatment is not intended to seal the barrel, but to protect the wood from external moisture, limit water absorption, and slow the aging of the material. The interior remains untreated, preserving the natural properties of the wood for the storage and conservation of liquids. After these steps, the wooden barrel is regarded as complete. Without the use of glue or synthetic coatings, its durability and water tightness depend entirely on precise geometry, the pressure exerted by iron hoops, and the natural swelling of the wood, core principles that have sustained traditional cooperage in Sünwald for generations. From the forests of Sünwald, where oak is split along the grain and bent with fire to form watertight wine barrels, the barrel's journey does not end in the cooper's workshop. Leaving the village of Ellern, it enters the circulation system of the pre-industrial wine economy, tied to viticulture and transport along the Rhine, especially in the Siebengebirge, where wooden barrels functioned as the standard unit of wine transport. Within this context emerged the vineroder trade, a specialized link in the chain of wine production and circulation. Practitioners of this occupation carried and hauled barrels from deep cellar vaults to the riverbanks, directly connecting the cooper's finished product with the Rhine's wine trading network. Along the Rhine River, the Siebengebirge region and the communities of Nieder and Oberdollendorf emerged as Germany's northernmost wine-growing center from the 10th century onward. Alongside wine itself, the profession of wine porters became an essential link, carrying heavy barrels from cool cellars to the riverbanks, and helping spread the reputation of Siebengebirge wine along the Rhine. From the 19th century onward, viticulture in the Siebengebirge entered a prolonged period of decline. The outbreak of the vine pest Reblows in the 1880s devastated vineyards and forced many families to abandon the trade. In the early 20th century, industrialization and socio-economic change further weakened traditional wine growing as agricultural labor shifted to nearby factories. After the First World War, vineyard area still covered about 100 hectares, but gradually shrank to roughly 10 hectares today, due to land fragmentation, the loss of successor generations, and accelerating urbanization, particularly after 1949, when Bonn was designated the provisional capital. Facing the threat of complete disappearance, viticulture in the Siebengebirge was sustained through the land consolidation reform of 1977, which merged fragmented plots and reorganized vineyard structures to improve economic viability. Today, only a few wine estates in Nieder and Oberdollendorf, such as Sulz and Broel-Bluser, remain active, preserving traditional wine-growing practices and safeguarding a historical landscape shaped by the Rhine. With the advance of mechanization in wine production and transport, many traditional crafts were gradually displaced from working life. Machinery replaced human labor, erasing not only jobs, but also skills passed down through generations and the occupational communities built around them. Among the most characteristic was the vineroder, wine porters responsible for loading and moving wooden barrels, once indispensable to the wine economy of the Siebengebirge, but surviving only until the 1960s, when the last manual practices, such as those at the Breder estate in Niederdollendorf, quietly passed into history. The vineroder, specialists in loading and transporting wooden wine barrels, operated as professional transport contractors in earlier times. They were responsible for moving barrels from vessels on the Rhine into wine cellars and for carrying them back again when the wine was dispatched. From the late Middle Ages onward, the Weinschröder organized themselves into associations known as Bruderschaften, occupational communities marked by discipline and mutual support. By the 19th century, they were commonly employed by local authorities, wine growers' associations, or wine estates as needed, and the term Schroten appears in historical documents and illustrations, attesting to a once widespread occupation closely linked to related barrel handling guilds such as the Fassier.
So,
Du musst es mit beiden Knie oben runter gehen. Schließe weg. So, Norbert, das kannst du hochheben. So, geh mal an. Nehmen wir das Ding perfekt und höher. So.
Before transport, the Weinschröder carefully cleaned the exterior of each barrel, removing dirt, dried residue, and traces of mold to ensure safety and control during movement. The water used for this purpose was drawn from a small auxiliary wooden cask known as the Stitze, which also served to lubricate pulling surfaces, reducing friction and risk. They also possessed practical knowledge of barrel construction, enabling them to secure loosened iron hoops during rolling and hauling. Tools such as the setz, hoop setting tool, and the Schläger, hammer used with the setz, were employed to tighten the hoops and stabilize the barrel. In the cellar, barrels were placed on raised supports to avoid dampness and wedged with wooden Schließen to prevent rolling. At the Breder estate, the cellar could hold up to 64 footer, each about 1,000 liters and nearly 200 kilograms even when empty, underscoring that this was a form of labor dependent on collective effort rather than individual strength.
So, fertig, jetzt hoch. Weiter. Stopp. Und absetzen. Auf, hoch. So ist der Länge. So, und noch was. So. Das ist der erste Frühstück für dich. So, ist gut. Gut. So. So, wir stützen jetzt mit dem Wasser. Guck. Komm, Jonas, nimm mal hier die Stütze. Damit dann hier. Komm, nimm mal die Stütze her.
ja, ist gut.
Damit haben wir dann hier Schrot lädt.
To remove a barrel from the cellar, the Weinschröder prepared levers for lifting and alignment, iron hooks to secure the load, and ropes to transmit pulling force. A specialized wooden ladder, known as the Schrottleiter, was laid from the cellar floor to the entrance, functioning as a sliding track. Its surface was lubricated with animal fat, soft soap, or water drawn from the stitze, reducing friction and allowing the heavy barrel to be moved in a controlled manner. Given the immense weight, the Schrottleiter had to be firmly anchored at the top of the cellar entrance. Meanwhile, a horse-drawn cart stood ready in the yard to transport the barrel onward to the river. Before pulling began, the Weinschröder carefully checked the stability of the ladder, the anchoring points, and the angle of ascent, as even minor misalignment could lead to serious accidents. The rope was attached to the barrel with iron crampon, usually fixed at the tap hole near the base. The narrow, steep cellar stairs made this stage the most physically demanding part of the operation.
Hier fest. Oh, ruhig noch fest. Ah, jetzt klappt mit dem Krampfen. Was an, so wir ziehen jetzt hoch. Pass auf, jetzt hoch. Stopp. Stopp.
In the period before mechanical pumps, barrels were sometimes hauled out while still full, or the wine was drawn off in stages beforehand. During the haul, iron hoops could loosen and had to be tightened immediately. In addition to wages, the Weinschröder received Schrottwein, a customary allotment of work wine, both a practical source of strength and a symbolic acknowledgement of the arduous and hazardous nature of their labor.
Einen größeren Hals wie wir.
After the wine barrel was brought into the yard and its iron hoops securely reset, the Schrottleiter was placed on the cart to stabilize the load. Using coordinated group effort, the Weinschroeder lifted the barrel onto the wagon, after which it was disinfected with sulfur, a standard procedure in traditional winemaking. Strips of sulfur were ignited and placed inside the barrel to fumigate it, killing bacteria and mold. This process was known as Geschwefelt. Once the sulfur strips were inserted, the barrel was sealed completely. The bung was wrapped with bast fiber to improve tightness, and the lower outlet was closed to retain the sulfur fumes inside. After the sulfur had burned out, the fumigation strip was removed and a hand pump was fitted for filling the barrel.
Norbert, nimm von dort, von der Seite auf den Schließfach.
Opening a full wine cask in the cellar and swiftly replacing the bung with a spout required skill and precise coordination. The operation had to be executed quickly to minimize spillage, for, in a craft-based system dependent on wooden barrels and human labor alone, every lost drop represented wasted effort and economic value. Wine was pumped from the full casks in the cellar into empty barrels set in the yard using hoses and a hand pump. To ensure a steady flow, the upper bung was loosened to prevent negative pressure. At first, a small amount of wine might seep from the lower opening, but as the wood absorbed the liquid, it quickly swelled and sealed itself, an inherent and reliable property of wooden casks. As the barrel neared completion, the Weinschroeder tapped the staves to gauge the fill level, ensuring the cask was topped up to minimize air contact and protect the wine during storage and transport. Each barrel required roughly half an hour to finish, after which it was tightly sealed and made ready for departure. In places where loading was infrequent, transport to the river was often carried out by local carters as a form of neighborly assistance. Until the 1920s, the site of today's ferry crossing served as a loading point for wine barges, marking the final link between the cellar and riverborne trade along the Rhine. The modernization of winemaking fundamentally transformed systems of storage and transport. Steel tanks replaced wooden barrels, electric pumps replaced human labor, and motorized tankers took the place of horse-drawn carts. These technological advances improved efficiency and technical control, but at the same time led to the decline and disappearance of many traditional crafts. Alongside the contraction of traditional cooperage, the work carried out by the Weinschroeder, the wine barrel porters and haulers, was also removed from the wine distribution chain. Once occupying a central position in the pre-industrial wine economy, this occupation no longer serves a practical productive role today and survives only in historical records, documentary films, and efforts to revive traditional crafts. The disappearance of the Weinschroeder reflects the broader transition from manual labor to mechanization, leaving behind a layer of cultural memory embedded in the landscape and history of the Siebengebirge. The traditional crafts of Soonwald and Siebengebirge represent two inseparable stages in the pre-industrial wine value chain: the fabrication of the container and the organization of circulation. In the forests of Soonwald, coopering developed through the selective use of oak and the precise application of material principles, from splitting wood along the grain and bending it with heat and moisture to assembly by mechanical hoop tension, producing watertight, durable barrels suited for long-term storage. In this context, the barrel was not merely a handcrafted object, but the central technical unit of the entire wine production system. Once leaving the forest landscape in the craft village of Ellern, the barrel entered the circulation network linked to the wine-growing regions along the Rhine, particularly in the Siebengebirge. Here, the barrel's role as a standardized transport unit gave rise to the vineroder trade, a specialized occupation responsible for loading, hauling, and moving wine barrels from deep cellar vaults to the riverbanks. Organized in professional communities with defined roles, labor discipline, and mutual support, this trade reflected the social structure of pre-industrial guild-based economies. The decline of both crafts unfolded alongside the processes of modernization in the 19th and 20th centuries. The replacement of wooden barrels by metal tanks, the introduction of mechanized pumps, and modern transport systems severed the traditional links between raw materials, manual craft techniques, human labor, and river-based trade routes. Skills that had once been foundational to the wine economy gradually lost their productive function and disappeared from everyday practice. Today, coopering in Soonwald and the vineroder trade in Siebengebirge no longer operate as functional components of the economy. They survive instead in archival records, documentary films, and efforts to preserve occupational heritage. Studying these crafts allows us to reconstruct a production system rooted in natural materials, human labor, and experiential knowledge, one that shaped the landscape, society, and economy of the Rhine region for centuries before yielding to the logic of industrialization. Thank you for staying with us to the end of this story. If you enjoy documentaries like this, please like, share, and subscribe so you won't miss the next one. Raw Machines. Thanks you, and we look forward to seeing you again.